So in this example, we will see how we can use this new formula. Let me write it delta equal, remember that formula? What is that formula? F times L divided by A times E. Make sure I don't make any mistake. How we can use this formula to find forces in a system that is undetermined. So meaning in this example, let's start to do the free body diagram. Okay, so if we do the free body diagram of this example, we have the beam like this. We have a force, so we know W. Let's say W equals 5,000 pounds. Okay, so we know W going down. We have two cables, so we have a cable at A. I will call that equation, that force TA. One force is at B, TB. Okay, get down. And we have a pin connection at this point. Let's call that point O. So we have also OX and OY, like this. So I hope you can hear my sound. The question is, how do we solve for unknown with only 3 equations of statics? Remember, we have some of the forces. Oh my goodness. Some of the forces on x equals 0. Some of the forces on y equals 0. We can use also an equation of moment. Let's say about O equals 0 because we have 2 unknowns, so we want to use the point O, but we still have 2 unknowns in this equation, TA and TB. So we will work on that. Let's give some data. What do you want? We are in pounds, so let's give some data in. I will use something big and let's put them orange so we can see them well. We will have all the data, that doesn't matter, in feet. Let's say this is 2 feet. Let's say this is 3 feet. Let's say this is 4 feet. And let's say LA, it's 5 and 6. 2, 3, 4, 5, 6. Okay? This is all dimension in feet. Okay, so there is a first equation that we will use that we learn in statics. That's this famous equation of moment. So let's do some of the moment about O equals 0. What do we have? We have TA that creates a positive moment times 2, this distance, plus TB times the total distance from O. Yeah, I know I keep touching that. So this is 2 plus 3 times 5 minus the weight W times the total distance. So this is from there. Total distance from O, that will be 2 plus 3 plus 4. So we will be at 9 times 9 equals 0. So we can write this equation 2 TA plus 5 TB equal 9 times 5,000. Okay. We like to write our unknowns to the left, known value to the right, so we can put that in the matrix system at the end. And let me put the data at the same time so I can check. 2, 3, 4, 5, and 6, and we have a weight of 5,000. I know you don't see what I'm doing, but I'm making my calculation. So we need to find another equation. We need to find another equation, and that's where we will use this equation with delta. Okay, so let's move that free body diagram to the right. We are done with it. And let's now look at the deformation. So we were this, and now it's getting down like this. Okay, this distance is delta A. This distance is delta B. And we have another delta, but we don't care too much about that. And we have this distance from there to there equal 2, and from there to there equal 5. And what we can write with the similar triangle rule, we can write that 2 divided by 5 equal the ratio of dA divided by dB, because dA and dB are parallel. Remember that one? So we can write that 2 dB equal 5 dA, delta. I said d, but that's delta B delta A. And now we will use this formula, and we will plug them into this one. So we have 2 oops, 2 FA, FB, LB, AB, EB equal 5 FA, LA, AA, EA. Okay. We assume in our example that the two cables have the same Young modulus and have the same area. So we can write that 2 FBLB equal 5 FA, LA. For those LA and LB, that's the initial length. That's the data that are given there, the 5 and the 6. So LA was 5. So this one is 5. And the LB was 6. See this one, those value in red. So we have 2 okay, equal 5. Okay, and I will rewrite that, rewrite it better. 2 times 6, so 12 FB minus, I will move this unknown to the left, so 25 minus 25 FA equals 0. And this is our second equation. So let me highlight them there. I want this task manager to go down, but I don't know. Don't have luck today. So we have this first equation there and this second equation. Very convenient to unknown. We can plug that in a matrix. So the matrix will give us, we will have TA at the beginning, TB after that. So 2TA, I use the first equation, this one. 2TA plus 5TB equal 9 times 5,000, 45,000. You can write it, 45,000. And on the bottom, be careful I wrote F, but that's a T, okay? In our case, it's a T. So this is minus 25 TA plus 12 TB equals 0. So minus 25, 12 equals 0. So we ended up having this matrix that we inverse time this matrix, and that will give us the value of TA and TB. TA is equal to 3,624 pounds, and TB equal 7,550 pounds. Here we go. We have our solution. So we see now we are able to find some forces when our system are one more unknown than equation with the statics equation, with the equation of equilibrium. This is wonderful. And there's a lot of different examples, more or less difficult. What you need to remember is like the strategy to use those ratio between the displacement and some kind of the geometry that you know, because when the structure move, they have some link together. Okay, so the D delta N delta B, they are linked together. They cannot be completely independent. So that's what we need to use. So remember to use those displacements and the geometry. And of course, some equation of statics. So hope that makes sense. Let me know if you have questions. Bye-bye.